So I'm Mason with Object Rocket here, and that's David right there, DBA lead with us. Before we say anything, Nikki wanted me to say that we're live streaming everything that's going on here, so apparently don't say anything too obscene. I think is what she's getting.
No, we want people to be able to ask questions in the chat and we'll answer them.
See, I would forget something. David is going to go over the bulk of this. I'm gonna start it off with a piece on Mongo authentication here. Okay. I'm just going to flip slides for me, apparently. That's what we're doing overall, though. The first part is all the custom role stuff in Mongo 2.6. Then David's going to go over all the new indexer and optimizer stuff. And there's a whole bunch of operational improvements that we're going to try to get out as well. So. All right, so up until this point, Mongo has had pretty simple RBAC as far as what it offers. Just a few roles, user admin, cluster admin, that sort of thing. And you haven't been able to do very much fine grain. With 2.6 comes a whole fine grained RBAC system. So we now have resources and privilege actions to provide exactly what we want to a specific user, be it for your application or one of your developers or DBAs. The resources are going to be pretty simple. Cluster is the overall installation, so whether you're sharded or whether you're just a replica set, the entire shebang. DB is the DB level, and collection is just for a collection. There's some interesting ways you can use those we're going to do later. And then privilege actions, this list is huge. Those are just a few little ones. This is basically any single thing you can do in a MongoDB. So anything from as simple as a find to different things with a profiler and all that sort of stuff. So.
Thanks. And in case anybody doesn't know, when he says RBAC, he means role-based access control. Anybody had that question?
Fair enough. And this is kind of what I just went over with the different resource types. So these are basically the pieces that you're defining access over. So for our cluster up there, we're defining, overall over my entire instance, I want the action call mod to be enabled for this user that I'm creating this role for. Then on the DB type, we're specifying a specific database and collection, again, with call mod as the action. And for the collection type, this is actually pretty interesting. You see DB is empty in the quotes, and the collection is defined as bar. That means that any collection named bar on any database is actually going to have these actions available for the user that's given this role. So you can see there's some kind of interesting ways you can combine those. And as I said before, the privilege actions, the thing you can grant a user to do, every single thing in Mongo is broken out very granularly. So there's a huge list of those in the Mongo docs. If you're going to go about creating custom roles, definitely recommend you read it. It's very cool. You can pick just about anything in Mongo, and that's all listed right on their site. And this is just kind of an example of what a user might need. So read, write, obviously, your query, your update, all the stuff you would do to do normal database options. Call mod for changing things in collections like TTL and that sort of thing. And then plan cache read, which is one of the newer 2.6 features that I think David's going to hit on a little bit more later. But it's kind of a souped up version of the profiler and something that's been enabled in other databases before. A collection that you can actually go through and see query plans that have already run. So, and this is a big broken out example role, and there's a whole lot of stuff in here. So using that create role action, name a role, expanded rewrite. And then everything down there, all the privileges and different things we're going to do. So you can see here we're defining our resource, kind of like some of the other resource docs. So in this case, it's appdb, and it's any collection in there because we like collection blank. And the actions in the plan cache read I just mentioned and call mod. So that's what that user is going to be able to do from our custom perspective. And then right under that is super useful if you're going to actually be creating roles. You can have a role inherit things from one of the default MongoDB roles, and they actually added quite a few of those. So there's probably about 15, 20 of those right now. And in this case, we inherit for read-write. So anything that the read-write role has, our custom role also has on top of plan cache read and call mod. And we're assigning that the read-write role from the appdb database. So you can pick a specific database's role to inherit from. And this is noted in the docs as well, but in this case we use write insert majority to make sure that this actually propagates to the majority of our cluster members. And that's a kind of a basic rundown of what create role is. Anybody have any questions on just creating a role and different things you can do inside of there? All right. And again, pretty simple. So we're going to take that role we just created, add it to our app user when we're creating the user there. Password, et cetera, and again, using the right conservative majority. Unlike using db.addUser before, where you could kind of just pick a user and a password, now in 2.6, you're always going to want to use create user. If you use create user, you don't define a role, it's actually going to have no access to anything. So it's pretty important to actually figure out what roles you're going to want to give to each of your users before. I think that's probably what we have as far as slides, right?
You said there's lots of different roles that you can assign somebody. So if I constantly want to assign the same roles to like a particular user group, can I, like, what would be the best way to do that? Do you have to copy and paste every single row every time?
Right. So there wouldn't be like a concept of a group in that sense, right? But it's as easy as creating a role beforehand, and each time you add a new user, you just stick that custom role that you created right there. That would be kind of
if you're wanting to solve that type of problem, you might look at the enterprise Mongo, because that's going to have the LDAP integration, and so you might be able to do some interesting stuff there as far as, hey, this user from LDAP or this member of a group from an OU and LDAP is actually becoming this user on the system, and therefore they get these roles. And you could do some interesting stuff where you change it in the upstream, and then you allow access or disallow access, and then you're not constantly. But that's also part of the point of adding roles like this, so that you just add it one time per user, and you reuse the role that you created. Because what you could do is you could create several different roles that fit different things, and then just add all of those roles to that one user, and then he'd have scope for all the different databases, all the different collections you want him to have access to.
Definitely. That's a good point. If you are an enterprise customer, you have not only LDAP but Kerberos, so there's a lot of cool stuff you can do in there. But as far as the community edition, basically, as we've been saying, you're going to want to create the roles beforehand, and then it's easy enough to just stick them in create user. So
do you have any questions on that? I know you covered a lot right there.
And probably talked way too fast. So if anyone has any questions, go for it.
When you upgraded a database that had users without any roles, what happens there?
They should keep what they have currently, which is just if you just created them without any roles, because there are right now, default roles. But they should keep what they have right now, which would be a default rewrite in case of.
Yeah, basically anything created with add user is going to have that default read write, but anything that is created with create user, which is the new command they added in 2.6, is going to behave very differently. I haven't actually tested this, but I'm pretty sure you can't provide an empty array to roles in create user. Pretty sure it kind of keeps you from doing that accidentally. That said, I haven't tested it. I'm assuming that it was enforced that way.
I believe you can do just an empty string for role, and I think the docs actually mentioned that, is you could do that to not define a role right away, which they basically say, well, why would you do that? Because it can't do anything after that. But it is available. But no, as far as I know, all users are going to port over having the exact same functionality they have right now. So.
Yeah, and the real use case for all of this is there was, in the old role system, you had a situation where you would give somebody full read-write access to a database, but to enable Power of Twos, you needed call mod, and that was an admin function. And so you had to give them cluster-wide admin, even if you didn't want to expose like add shard, remove shard, shard a collection, all the other wonderfully dangerous things like the actual shutdown command. And so this was a way to try to bring a little more of that traditional database foo around locking down to specific commands. I haven't looked, the list is pretty exhaustive, but I'm pretty sure it doesn't carry over to every command. And there is some options for using it. There's a special root privilege that you can provide that gives just carte blanche access to everything. Be careful with that one. If you can use it, but just be careful with that one because it's like the traditional admin from the admin database that you had in 2.4 and below. Any other questions?
Revoke, how do you revoke the user command for that?
For what?
How do you revoke the grants?
To revoke the grants, you would just, there's I'm not sure if it's change user.
It's either change user or some form of modify user.
Yeah, it's either modify or change user. It's another new function that came out where you can actually say unset this role, and then that's effectively revoking it. Or you can just remove the user completely if you don't want that user at all anymore.
Okay. All right. Anything else?
All right, I'll move into my section.
I'm giving you this job. And get some pizza.
Yeah.
Revoke roles from user. Okay. Thanks.
What was the question?
It was how do you revoke a role? Like how do you remove access to a role? Like so, you have a user, you've given them an expanded role, like they have access to, I don't know, see server-wide status details, and you decide that you don't want that user to have that anymore because they're misusing it. Then you would use that to remove their access to that specific role. Or maybe you just broke a role and you deleted it, created a new one, and you wanted to switch that out.
And you can also add extra roles by granting additional roles to the user, so you don't have to do it within create user. And then you can revoke individual roles by name.
All right, so there's a lot of new changes in the indexer and optimizer. I wanted to cover a few of the ones that I and the team really found useful in general. So the main ones I wanted to cover were the query cache planning, which Mason was talking about earlier. The index filtering, which think of it like high level would be think about it like where we were hinting before in 2.2 and trying to get it to pick the right index. Now we can do the opposite to say invalidate these other indexes completely because I don't want them to be ever used because I know they're horribly bad. I don't want you to make a mistake with it. And then the other one's index intersections, which is something a lot of people have been coming to me and asking questions about. So I wanted to go into the details around that. And then also its limitations, because you had to go through a fair bit of documentation to actually understand what it couldn't do. So, query plans, it's from, Oracle's and MySQL's have had this for a while. MySQL's not really exposed, but the way it works is every time you run a query plan was figured out, you were exposing it through explain before. Today, in 2.6, what we can actually do is we can say, for a given collection, show me all the plans that you've figured out so far from all my query types so that I can review what the plans look like. And you can even use some commands here to say, hey, I have this query, give me the query plans for that one. So it's basically like explain. You can still use explain, but you get that expanded view so you can see how that is. You also have, not in the role that Mason exposed, but there's another grant that I think it's clear plan. That will actually literally let you clear specific queries out of the plan cache or the whole cache to cause it to rebuild that cache because you changed something drastically and the database was making bad decisions. By default, let's see, what are the rules around that? I think, no, I don't talk about it. I think the rules around that are, let's see, every 1,000 inserts you make, it's going to force a plan to be reevaluated. And then also, I think if you add an index, and there's one other reason I can't remember right now that's in the manual. There's different things that large operations on the database that will actually, and the collection that will actually cause a plan to be invalidated and rescanned. But the most important thing to remember is every 1,000 inserts, it's going to be rescanned. So just plan for that overhead. That's an overhead we've always had, so it's not really a change, just something to be aware of. And so that's how it's recalculated on those rules. And like I was saying, and we explained there's the clear and there's the read options around this new profiler. As I recall, it's not in read write by default. It's something you specifically have to create or add a role for. Otherwise, you're just not going to get that access without adding access to the database. And then I want to talk about index filtering. So traditionally, where we're at is we could say, hey, I'm running this query. You're picking this index. I want to kind of tell you that I'd rather you use the _ID index than the, foo bar index. Well, that works sometimes, but sometimes it didn't really listen to us. And with filtering, we can actually go in and say, no, absolutely don't use foobar, use ID. And so it's a more restrictive access, and it's a little more absolute in its use case. So you should probably be careful there, because if your query pattern changes and you don't know it, like your data set changes enough, then you could actually like force yourself to have really bad index optimizations. And you have an index that just doesn't get used, but it should have been used, and you kill your performance. It's actually something I plan in our service to watch for people doing, because I have a feeling it's going to get misused very quickly with people that aren't constantly monitoring the cardinality of their data. So it uses a shape. The best way to describe the shape, it's like a hash in other databases, but it's just an amalgam of different parts that make it up. Like for example, when I'm playing the profiler, I actually take all the keys that are in a query and I summate them, and I do counts of how many times that query ran, so I get a query pattern. And in other databases, that's what a shape is. It's a query pattern. This one goes a little bit further because it has sort and projection, and traditionally you only did it on filterable fields. But using hint and filter, you could almost create a locked plan. And anybody that's done Oracle knows all about locked plans and how you could actually just say, hey, don't change the way you access this data until I tell you to, because I know the access pattern I want for this data. Mongo's getting close. It's not fully there, but it's a huge step forward to have this feature. And then index intersection. So before I get into that, does anybody have any questions on the previous two? Because those tied in kind of close to each other. Okay, no questions on the live stream, Nikki? Okay. So index intersection, basically, up until this point, we could use exactly one index. It could be a compound index, it could be a multi-key index, or it could just be a normal hash index to find any piece of data in the database. A lot of people found this to be problematic because they needed two different indexes that didn't fit nicely together, so they had to create all sorts of different versions of that compound index to cover all the access patterns they were going to need. Like I needed a range in this case, but I needed constant in this other case. And so a lot of people got really excited about this concept, and they were like, hey, I can just create tons of single field indexes and it'll just smash them together. You can't. It's only two fields right now. They're looking at increasing it in future versions. It's a hard limit there. And then on top of that, a compound index will always be faster, because what we're doing in it is we're just doing a union. So traditional database, you took this table and this table, and then you compare the differences of what you found, and then you spat only the ones that matched up out. That's all this is doing in the same way. But what's happening here is it's not nicely computed, and so it takes some extra CPU time. CPU time is very sensitive in Mongo because we have the single database writer lock. So just be aware that there's some extra cost, especially with like things like updates, where you're going to extend your write lock period. And the main case is something called self-intersection, and it has to do with like multi-keys, where you actually have, I don't know, an array of products, and you have like, I don't know, description and quantity and for the current inventory and price, and you want to do a mashup of these things. And before you couldn't use multiple indexes because you could only use one multi-key, but now you can do self-joins, and the 2 index limit does not apply here. So you could like have a structure where you have an array of different fields and actually create a union between 4 or 5 of those if you wanted. It's not really that performant from the tests that I've made, because it has to unwind an array and then get you your data and then return all of that. But it just simply wasn't possible before, so there is that. So one of the things they talk about a lot of the documentation that's not super clear is the fact that when you're doing a union and you're doing a sort, they have to be in a very specific order. Otherwise, you will not be able to use a sort using an index, and then that's going to create all sorts of lovely memory and performance problems for you in Mongo. So that's kind of them in a nutshell. I think I had another slide. Yeah. Some basic rules to remember. You're only really going to use it if you do not have your full hot set in memory, which sounds kind of interesting to me because the big thing that is typically pushed in Mongo is to have everything in memory, if at all possible, and have your hot set as hot as possible. And so this is kind of diverging from that. And it's mainly because the performance of NRAM is so much greater than the performance that we have on disk. And so they're trying to make these optimizations to make those disk grabs a little bit cheaper. You have to use the predicates that you enter into each index that's going to be unionized has to be a constant. It can't be, hey, I want everything from January 1st to January 31st and for an update time, and I want everybody that was created before, I don't know, June of the previous year. Like, you're not going to be able to do an intersect on that because if you think about it from a joining perspective in traditional databases, what you're actually doing is you're asking for a Cartesian, which is basically examine every row by every row. And that's extremely expensive in any database technology. And so they specifically prohibited it from use here. Also, neither index can be super selective, which is interesting. So you can't have something that has a super high cardinality and then intersect it with something that has a super high cardinality because it thinks the result sets are just going to be too small and it's not going to do it. I haven't really talked to developers too much on why that is yet, because it seems like there's a line that you need to figure out where that best performance really is. And also, if the estimated output of an intersect is deemed large, think about it like a table scan, the optimizer is going to automatically say, hey, I'm not going to use this type of plan because I would be scanning too many documents, I would be bringing too much into memory and returning too much. It just doesn't make sense. I'm not gonna help you. I'm just gonna make your situation worse. So, does anybody have any questions on those rules in general? That all make pretty much sense. Pretty good sense. All right. So this gets to operational improvements. The first one is something that everybody in Object Rocket has become acutely familiar with, and that is in Mongo 2.2 or 2.4, it didn't matter. If you needed to build a new index and you had a very large data set size already, you would run into a situation where if you tried to build a background index, both your secondaries would fail at the exact same moment. And that was because when that index actually got to them to replicate it, they both received it at the same time, they both started at the same time, and they both failed heartbeats at the same time. And so we have a whole process where we take nodes out of the set and add the index and then turn it back, add it back in and do the next one, and then add the index on the primary. You can step down the primary, you can do it online as a background, because ensure index is just gonna go, oh, I already have this index on the secondaries, I don't need to do anything. Well, now background index actually works properly. There's a couple things that they changed. They've made it to where it doesn't block heartbeats, which means your cluster doesn't fall apart on you, but also that it is safe to actually do that background index, and it's not gonna affect the way operations play out from the op log, which is then gonna cause all sorts of problems, and it doesn't miss new items being inserted from the op log so that the index gets fully covered. And that's really important because that was why they disabled it. And so operationally it's a huge win because none of us have to worry about that. All we did do is make the index as the background, and the system's simple now. We don't have to worry about weird little race conditions we have to deal with. Orphan cleanup is a little bit more interesting. So orphans exist when a migration occurs from shard A to shard B, and the delete cycle does not finish successfully. There's a plethora of reasons that can happen. There's a one-day timeout, there's you're using change secondaries, there's just, you had an election in the middle of that process. Tons of different things that could occur there. And what happens there is the data just sits there. The problem is, on a primary, there's certain protections in place with something called chunk managers that you can read about. that actually filters them out. But if you're doing secondary reads, the filters does not exist. And because of that, you were running into situations where accounts could be drastically off or just slightly off or fine. It really depended on the workload you had, the number of orphans you had, and were you reading from secondaries. And what Orphan Cleanup does is it's actually a tool that goes in and helps find all of those and gets rid of them. I would say that we should be careful with using it, just like anything in Mongo 2.6. It's a new product line. We need to really give it time to mature, make sure there's not odd bugs, especially something that's data destructive like this. And that's kind of the high level. Orphans are pretty hard to detect because you're constantly splitting chunks or moving chunks around. You can disable the balancer, but splits still occur. And so running a count of orphans yourself isn't very accurate today. But I've seen some customers that hit huge amounts of orphans, and this is a big deal. It'll save them a lot of trouble. So play with this in dev, just like you're playing with 2.6 probably in dev right now. But just be very careful and cognitive in your testing of it because it is data destructive. So you don't want to just assume that it's doing the right thing. The new write operation protocol is kind of interesting. So they completely changed when you used to do an insert or a delete, a remove, or an update. It would just go into the system, it used get last error, but under the hood it was just one command. It didn't care what it was, the database figured it out behind the scenes. Now they've broken it out into commands, and they've done some implicit things with get last error, but they've also changed the way bulk works, and I haven't really played with it too much yet to see how much I like the new system or not like this new system. There's some points that will raise the performance quite a bit for the way writes work. However, you can't have your cake and eat it too. It sacrifices some other stuff from making sure in a bulk insert that everything was done in the right order or was completed correctly. If I remember right, in the new bulk system, it will just return one error and you don't know, no, it'll return a set of errors for all the writes that failed, but you don't know which error. And so that gets to be an issue because before it would just stop on the first one and you could just kind of restart the job and figure it out. Now you could have 30 errors that you have to go troubleshoot all 30 before you really know what to do with that set of data. And so there's a lot there. I'd really like to discuss it more, but there's a lot to it. The manual is pretty thorough on it though, so I would go read it. It's one of the major changes in 2.6 from an operations perspective that DBAs and developers would need to know on how it changes performance characteristics. The other thing, I don't know if any of y'all have run into this, is traditionally you could have an index on a text field. And when you did that, there's actually a max limit of characters that an index can contain currently, a max size for each entry in the index. And you would get a warning message in the MongoDB or the MongoS layer. Now, instead of just giving you a warning, it's a hard failure. So where you were inserting successfully before, you're now going to get an error code. This means that you need to test 2.6 very, very thoroughly in your code because it's going to be a real problem where all of a sudden writes are going to start failing for your customers and you might not know why. If you had this problem before, you upgrade and then it takes a few days to find it. You're going to be very upset and trying to figure out how to solve that problem. Don't think it's going to hit a lot of people. I've only seen it a handful of times. Mason, how many times do you think you've seen that? 4 or 5?
I would say maybe 5 or 6 times.
Yeah. So it's not a super common problem, but it is one that exists. And the other big operations of improvement that we use and have used for a while now is setting everything to power of 2. And does anybody know what power of 2 is? Okay. So power of 2 is where you insert a certain amount of data and it rounds it to the nearest logical, like 1024. Like you inserted 1,000 bytes, it rounds it to like 1024. So you get a little extra padding on top of it. Helps with reducing moves and other things as you're updating documents. And we found that it can help with fragmentation, but it doesn't fully eliminate fragmentation. And all Mongo has done is they made Power 2 available for a while now, and now they're going everything defaulted to it. Cat Collections has been using Power 2. I think they started that in 2.4. I think so. Yeah, I'm pretty sure it was in 2.4. And that was just the default for that one. Now they've kind of promoted it to a default for everything. So does anybody have any questions on any of these main op improvements and how they actually affect you in production?
Actually, on the orphan cleanup, is there like a dry run on it? I mean,
No.
I would figure destructive commands should, right?
Yeah.
That's an excellent idea.
That is something that I mentioned when they were talking to us about it, because we were actually working on Python script that would find orphans, but we found that we could not stop splits from occurring, and then we're not, and
There's one right now.
and we weren't allowed to. I made a pull request asking for an ability as an admin to stop splits so that I could run that scan, and then I'd worry about splitting whatever did get split. But that got rejected because they don't want that model. They want to just clean up to occur. I believe right now that command is not automatic, and they were talking about for 2.8 making it an automatic command. So there's room for a lot of improvement. I'll see if I can find the original code where I had and ticket where I had done that pull request originally, and I'll let you. I can add to that to say, hey, we need a command to just list orphan chunks, and I'll send that out to the group so that you can vote up that issue, and then we can kind of go back to them as a partner and try to see if we can push them towards that, because it makes sense. I completely agree. But I didn't want to spend too much time on it, because they were at least making the command to actually clean them up, and before it was just kind of a dirty little secret of migrations and balancing that this could occur. So that's kind of the bulk of those, unless anybody else had a question. Okay, so the other thing I wanted to talk about is a feature that we actually launched today. Yeah, today, called automatic compaction. And basically the way it works is everything from an update, a remove, or even moving a chunk between shards will cause fragmentation in Mongo today. Just a lot. Fact of our life, it's one of the reasons your data sets will probably grow very rapidly, and a lot of people don't realize that that's the case. And we created a service that actually goes in and compacts secondaries, and then does a step down whenever a customer wants to do the step down, and then compacts that one as well to help shrink your data set size for you. It has some side effects. I mean, if you're very reliant on padding or other things like that, that obviously resets that whole system. And so there's a balancing act there. But I've seen customers drop huge amounts of data because they were using TTLs, or they were using almost a queuing type system in their code, to where they literally after compaction were 20% what they were before. I have other customers that have like a 3-day TTL, so we have to run compaction even more regularly than we allow in our system. So if you're not on Object Rocket, I would advise you to go read up our article about how compaction works, and then read up on strategies for doing that yourselves, because that's going to save you a lot of infrastructure in the long run, and it's going to speed up everything from insertion times to update times to just the overall performance in the hot set, because you're not going to have all these pads of 0 bytes sitting there in your hot set wasting space when you could have fit 20 extra documents, 1,000 extra documents, whatever. But here's my contact information and Mason's. You can reach out to us at Twitter at Object Rocket. You can send me an email. You can send Mason an email. My Twitter's up there too. But we're also hiring. We're looking for CDEs, which are not just support. They're a lot more. They're a little bit of an SA. They're a little bit of a junior DBA, a little bit of a networking guy, a little bit of a programmer, and every smattering inside of that mix. We're looking for additional DBAs. We're looking for developers, specifically Python developers with, can't think of the name of the Flask. See, I'm not a developer. And then a DevOps, which DevOps to us is, everything from virtualization, networking, load balancers, everything else. So if you know anybody that is looking for a new exciting job where you're really building new things and you're expanding horizons, talk to me, Mason, Kenny in the back, Eric in the back, any of us.
Or right here.
And Matt. That's right here, our recruiter. And Mason, thanks for coming up here. Does anybody have any questions? Not over this, just general Mongo questions too.
There's a question if we're gonna post the slides online.
Yes, it will be on my slide share and I will send that to the group. Anything else? All right, well, feel free to come up to us and ask us any questions. We're always approachable. Also, email us at any time. We're approachable there. Or, go to Object Rocket, try an account, ask Mason tons of questions.
We like the questions, so.